Hello everyone, Professor Vaibhav Shah here. Hope you have gone through all of my previous lectures and also lecture number 1, Introduction for Engineering Curves. If not, then I insist you to go and check all of my lectures and also the lecture number 1 first. These lectures are covering all the basic contents like what are engineering curves and its applications, understanding of conics with pictorial representation, classification of engineering curves, understanding of various engineering curves and its definitions, and nomenclatures that we have used in our previous examples and lectures. Now, in previous lectures, you can also see the methods to draw ellipse by concentric circle method, rectangle or oblong method, parallelogram method, and arc of a circle method. In today's lecture, lecture 6, we'll be learning about how to draw ellipse by Directrix focus method. And we are also going to learn loop method, which is a practical method which you can use in your real-time field. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. Let us begin. So now first we'll be looking after the step-by-step procedure to draw ellipse by Directrix focus method. So as the name suggests, Directrix focus. So in this case, we'll be needing one Directrix and focal point to draw our ellipse. So in this example, you will be given with two data. One, the eccentricity of an ellipse, and second, another data which will be showing you the distance of either vertex or focal point from your Directrix. So in this case, we'll be taking one data in which our focal length or focal distance is given. That means your focal point distance with respect to Directrix is given and your eccentricity is given. Always try to check your eccentricity for ellipse must be less than 1. So let us check the eccentricity in this case. So eccentricity is here given by 2 by 3. Obviously it is less than 1. That means this is the example of your ellipse. Now let us start. So first you will be drawing one vertical random line which will be of any suitable length. After that you will be identifying any point A and we have to draw one horizontal axis AA. After that, we'll be identifying this distance which is given as F1A, which is the focal distance from your Directrix, which is 50 in this case. So let us draw your 50 distance and let us mark this point F1. In this case, this is your point F1, which is at the focal distance from your Directrix. Now, after that, the eccentricity is given, which is 2 by 3. So let us remember the definition of eccentricity. So it is the ratio of distances of a point from a fixed point, that means a focus point or focal point, upon distance of that same point from your Directrix is constant and which is less than 1. So here let us take the point of the ellipse is as your vertex point V1. So here in this case, distance of your vertex point from your focal point divided by distance of your vertex point upon your Directrix point, it is nothing but your eccentricity. So that means in this case, F1 V1 by V1A would be your eccentricity and which is defined by 2 by 3. So once again, F1 V1 divided by V1A is nothing but your eccentricity which is given by 2 by 3. That means F1 V1 is of 2-part distance and V1A must be of 3-part distance. So that means we'll be dividing the total distance of your focal length into 5 parts. So let us divide this total focal point distance into 5 parts. So as you can see, we have divided into 5 parts. 1, 2, 3, 4 and 5. Now, what will you do next? So now we have to define point V1 on this focal point. So how to define point V1 on this focal point? For that, it is said that your vertex point V1 is 2 parts away from your focal point F1. So that means from your focal point, we have to go on left hand side 2 points, 1 and 2 parts. So we can locate easily our vertex point V1. After locating your vertex point, you have to draw one line perpendicular to this AA axis. So I have drawn one line perpendicular to this AA axis, which is your line from V1, 90 degree to your AA axis. After that, you have to take your rounder, put your rounder at V1 and take the radius is equal to V1 F1 and try to draw one quarter circle to cut this vertical line somewhere at point B. So after getting this point B, we'll join this point A with B and try to extend this line. So as you can see in this second figure, we have joined this point B with A and we have extended this line. After that, you'll be drawing another line from this focal point F1 at 45 degree. So you have to take your 45 degree set square and you have to draw one line from your focal point at 45 degree. Now, these both the lines, one line passing through this B point and the second line which is drawn at 45 degree will intersect somewhere here at point C. Now from point C, you have to draw one perpendicular line to this AA axis and this end point would be nothing but your vertex point V2, the another vertex point of your ellipse. After getting this vertex point V1 and V2, we have to measure the distance between V1 and V2 and accordingly we must divide this V1 and V2 into equal number of parts. So here we have divided this portion into 8 number of equal parts. After dividing this portion into 8 number of equal parts, we have to draw from each of the parts one vertical line. So we have drawn vertical line from each of the parts which is perpendicular to your AA axis. So you have to draw vertical line from 1, 2, 3, 4, 5, 6, 7 and 8 point itself is V2. So now we will mark these points vertical line which is intersecting this inclined line as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 7 dash, like that. Now after that what we have to do is, so in next case we'll be taking our rounder. On your rounder you have to take the dimension of 1 dash line here, 1 dash, select your rounder, dimension 1 dash, put your rounder at your focal point F1 and try to cut this line 1 dash here above and below. So you will be having this point P1 above and P1 below. Next, on your rounder, adjust your dimension of 2 dash of this line. Put your rounder once again on your F1 focus and try to cut this 2 line here, somewhere here and here. So you will be having P2 point here and here. Now, take the dimension of 3 dash on your rounder. Put your rounder at F1 and try to cut this 3 line here and here to get point P3. Now take the dimension of 4 dash on your rounder, put your rounder at your F1 focus and try to cut this 4 line here and here. So you will be having P4 on your 4 line. After that, select your rounder 5 dash distance and put your rounder once again on your focal point F1 and try to cut this 5 vertical line of 5 here and here. So you will be having P5 point on the line of 5. After that, try to take the distance of 6 dash on your rounder. Put your rounder once again on your focal point F1 and try to cut this line, vertical line of 6 to get P6 here and here. After that, take the distance of 7 dash on your rounder. Put your rounder once again on your focal point and try to cut this 7 vertical line to get this point P7 here. And after that, your final point would be V2. So in next stage, we'll be connecting all these points starting from your V1 till your V2 and your V2 till your V1 will be having one ellipse. So it is a simple method. So in which what we have done is we have first plotted the directrix. After that, we have drawn one horizontal axis AA. After that, we'll specify this point F1 by given distance of F1A from the directrix given distance 50. So we have plotted this 50 distance away from your this point F1. After that, we'll be using this eccentricity ratio which specifies F1 V1 by V1A. F1 V1 is 2-part distance and V1A is 3-part distance. The total parts are total 5 parts. So total focal length or focal distance is divided into 5 parts. So we have divided this focal length into 5 parts, 1, 2, 3, 4 and 5. After that, we have to draw a vertical line from V1. Then after we'll be taking V1 as a center, V1 F1 as a radius. We will draw a quarter circle and we will be getting this point B somewhere here on vertical line. After that, you will connect this AB and draw one line. After that, you have to draw a 45 degree line from your focal point. to cut this point C. From C, you have to draw perpendicular to your A axis to get your V2. After specifying V1 and V2, you will measure the distance of V1 and V2 and divide them into suitable equal parts. We have divided it into 8 parts. After that, you have to draw vertical line from each and every parts, and you will specify 1 dash, 2 dash, 3 dash, 4 dash, like 7 dash on this line. After that, we'll be taking a dimension of 1 dash. We'll be putting your rounder at F1 and try this line of 1 here above and below to get P1 point. Similarly, we'll be taking distance of 2 dash and we'll be putting our rounder on F1 to cut this line of 2 above and below to get 2 dash point P2. Similarly, 3 dash distance is selected and we have put our rounder at F1 and to cut this line 3 to get this P3. Similarly, we have to do the same procedure for each of the points, and after that we'll be just joining these points to get ellipse. So now let us see one example. Draw an ellipse if the distance of focus from the directrix, which is 35 mm, and eccentricity here is 3/4. So distance of focus from directrix is given. That means your directrix, your focus would be defined from this point 35 mm away from your directrix, and eccentricity is given. So first of all, let us draw the directrix D dash D, and from that let us select any point C somewhere here and draw one axis CC dash. After that, the distance of your focal point from the directrix is given 35. So let us draw 35 mm away your focal point, which is your focal point F, which is 35 mm away from your directrix. Now your eccentricity is given 3/4. So eccentricity is given, so 3 parts plus 4 parts, that means our focal length must be divided into 7 equal parts. So that means let us divide this focal length into 7 equal parts, and in which our eccentricity in this case would be FV/VC. So we have defined our eccentricity like FV/VC or CV. So that means FV is 3-part distance and CV is 4-part distance. So your point V must be 3-part distance away from your point F from this focal point distance. So we have to take 3-part distance away from your point F. We can define this point V, which is 3-part distance away. So if you try to measure this distance, it would be something 15 point something distance. So this is your distance 3-part away from your V, and obviously this remaining part would be your 4 parts. So we have totally divided this portion into 7 parts, and we have taken the distance FV as a 3 parts. So we have just plotted this point V 3 parts away from your F. So we have defined this point V. After defining this point V, we have to draw a random vertical line from this V, which is perpendicular to your C dash axis here. And after that, you have to take out your rounder, put your rounder at point V, take the dimension of VF on your rounder, and try to draw this quarter circle to get this point A on this vertical line. After getting this point A, you will join this point A and C and try to extend this line to get this extended line. After that, you will select any point F, focal point F, and from this focal point, try to draw 45-degree line. So we have drawn 45-degree line. We have got this point B. From this point B, you will draw one perpendicular line to this C dash to get this V dash point. After that, you have to measure the distance of vertex point V dash, and after that, measurement of the distance, you will be dividing the distance of V dash into equal number of parts. So let's say here we are dividing this portion into 12 number of equal parts. So let us give the numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. After that, to find out the minor axis, we will be finding out the midpoint of this V and V dash. So this is a midpoint O. From O, draw one vertical line. Afterwards, to get your minor axis as V and V1 dash. So now we'll start the procedure. So we have to draw vertical lines from each and every point from 1, 2, 3, 4, 5, 6. Draw vertical line from 7, 8, 9, 10, 11 and 12 is itself a vertex point. So we need not to draw a vertical line. After that, we'll be selecting on our rounder 1 dash distance. Put your rounder at F and try to cut this one line somewhere here, upside and bottom side, to get P1 and P1 dash. Now select on your rounder 2 dash distance and put your rounder at point focal point and try to cut this 2 line above and below to get this P2 and P2 dash. Now select this 3 dash distance on your rounder, put your rounder at F point, try to cut this 3 line here and here to get P3 and P3 dash. Select your rounder 4 dash distance and try to put your rounder at F and try to cut this line of 4 here and here to get P4 and P4 dash. Now similarly take the distance of P 5 dash on your rounder. Now put your rounder at F and try to cut this 5 line here and here to get this point P5 and P5 dash. Now select on your rounder 6 dash distance, put your rounder at F and try to cut this 6 line here and here to get P6 and P6 dash. Take the distance 7 dash, put your rounder at F, try to cut this 7 line here and here to get P7 dash. Try to select on your rounder 8 dash dimension, put your rounder at F, try to cut this line of 8 here to get 8 P8 and P8 dash. Similarly, try to take the on your rounder 9 dash distance, put your rounder at focal point, try to cut this 9 line here and here, so you will have P9 dash. Now try to select your rounder 10 dash distance, put your rounder at focal point and try to cut this 10 line here and here to get P dash and P10 dash. Now select on your rounder 11 till 11 dash distance and try to put your rounder at focal point and try to cut this line of 11 here and here to get P11 and P11 dash, and P12 point would be itself on the vertex point, so this is your final point. After getting these all points, try to connect it by your vertex point till your vertex point to make this complete ellipse. After drawing ellipse, if you measure this vertical distance from your O point, you will be getting V1 dash, which is your minor axis, so you can measure the distance. And now we'll be plotting another focal point and another directrix on the same diagram. So you have to take the distance of vertex and focal point from here on your rounder. You'll be plotting this vertex point in the inside direction, the point which will be your another focus point, which is F dash. And if you try to take the distance of your vertex point till your directrix, and if you try to plot vertex point till your directrix point, you will be having C dash, and from your C dash you can draw one another directrix by the similar distance. So this was all in example number 1. It is easy. You have to practice 2-3 times and you can master this diagram. So now let us move ahead. One more example. So now problem 2, point F is 50 mm away from your directrix line DD dash. A point P is moving in a plane such that the ratio of its distances from F and the directing line DD dash remains constant and equals to 2/3. Draw the locus of point P. Eccentricity is 2/3. So here it specifies a definition form. A point P is moving in a plane such that the ratio of its distances from a point is just like our definition of ellipse. We have to forget that. We have to just focus on 2 data which we required: point F distance, focal point distance from your directrix 50, and eccentricity is 2/3. So that means we have to first draw our directrix D dash D. After that we'll be specifying point C. From point C you have to draw one axis C dash, and after that we'll be specifying your focal point, which is here distance is given, which is 50 mm from your directrix. Let us specify your focal point 50 mm from your directrix. After that our eccentricity ratio is given 2/3. That means 2 plus 3 is equal to 5 parts. So that means your focal point would be divided into total 5 parts. And as we know, our eccentricity would be in this case FV divided by VC. So we have defined this eccentricity as FV by CV. That means FV is 2 parts and CV is equal to 3 parts. So if you want to find out our vertex point V, so we have to take 2 parts distance away from your focal point and we can find out our vertex point. So let us go 2 parts away from your focal point on the left hand side. So let's say 20 mm on the left hand side, we can locate our vertex point. It is obviously that the remaining distance would be of the 3 parts, which is nothing but your 30 distance. Now after getting your B point, you have to draw one arbitrary vertical random line. On this random line, you will take out your rounder. You will put your rounder at your vertex point V. Take your distance of VF on your rounder. Try to draw this quarter circle to cut this vertical line of V to get this point A. After getting this point A, you will connect this point A with C and extend this line into rightward direction. After that, you will select this point F, focal point, and you have to draw one 45-degree line to intersect this previous line at point B. After getting this point B, you will draw the vertical line which is perpendicular to your CC dash line to get your another vertex point V dash. After getting vertex point V dash and V, you will measure the distance between V and V dash, and you will divide this particular distance into suitable number of equal parts. Let's say here we have divided this particular line into 12 number of equal parts. Let us give numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. After that we'll be locating this midpoint O. So we have located this midpoint O. From this O, if you try to draw this vertical line, you will be having V1 and V1 dash later on after the example is over. So now let us draw vertical lines from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This all vertical line will intersect this inclined line at somewhere here. So we will be giving numbering 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash and 12 dash. After that we'll be adjusting on our rounder to take the distance of 1, 1 dash. So select your rounder, the measurement of 1, 1 dash and put your rounder at focal point F. Try to cut this line of 1 here and here. You will be having P1 and P1 dash here on your 1 line. Select on your rounder 2, 2 dash distance, put your rounder at F and try to cut this 2 line here and here to get P2 and P dash. Now select on your rounder 3, 3 dash distance, put your rounder at your focal point, try to cut this 3 line. So you will be getting P3 and P3 dash. Now select your rounder 4, 4 dash distance, put your rounder once again on your focal point, try to cut this 4 line here and here to get P4 and P4 dash. Select on your rounder P5, 5 dash distance, put your rounder at focal point F, try to cut this line of 5 here and here to get P5, P5 dash. Similarly, follow the procedure until you reach your 12th number point, which is itself a vertex point. After getting all these point intersection point, try to connect this point by a smooth curve. We will be having ellipse. Now, if you try to measure now the distance of V1 and V1 dash, it will be your minor axis of ellipse. Try to specify the minor axis as your answer, one of the answer. So now, very easy. We have followed the same procedure. So you have to follow the same procedure to get your answer. Now, let us look for your ellipse by a loop method in this case. So this is the ellipse by a loop method. This is a practical on-ground application of your ellipse. So now problem number 3, draw ellipse by loop method of 100 mm and 70 mm long diagonal. So first of all, from these diagonals, we will draw one horizontal line of 100 mm. After that, from the center point, we have to draw one vertical line of 70 mm long diagonals. After that, we'll be specifying its focal points. So how to specify the focal points? We'll be taking half of your major axis distance on your rounder and put your rounder somewhere here and try to locate 2 focal points on your major axis as we have derived in our previous lectures. After getting these focal points, we can actually draw ellipse by your loop method. So let us observe this video on the right hand side to observe how to draw ellipse by your loop method. So you'll be fixing 2 pins at the 2 focal points and we'll be winding out one string and we'll be plotting it by one pencil. We'll be rolling this pencil around this string to get this ellipse. So let us observe this image to get a better idea. So as you can see, you are just moving your pencil around your string to get your ellipse by this loop method. So this is nothing but a practical method to draw ellipse on any surface practically. You can draw ellipse by this loop method. So this is all from my side. Do not forget to subscribe my channel, share it with your friends and show some love and support. Keep learning, stay connected, and if you have any doubts or queries, feel free to comment below. Bye-bye.